Assalamu alaikum. In this project, we built a network where every node is a consumer item from Pakistan's PBS price data. Things like wheat, flour, petrol, sugar, and mutton, and an edge between two items means their price moved in a similar pattern across multiple cities in the same year. Today, I will explain how we measured that similarity and why the choice of threshold dramatically changes the shape of the entire network. We constructed two weighted versions of our graph. Look at these two networks on screen. They have the same nodes and the same edges, but the thickness of each edge is different in each version. In our code task 7, we define both nodes. Scheme assigns a weight equal to the raw count of cities that agreed on this co-movement. So if petrol and diesel moved similarly in all 17 cities, their edge weight is 17. This is the most intuitive reading. It answers the question, how many cities agree? Scheme B uses the average cosine similarity across all 17 cities. A city where petrol and diesel are almost perfectly aligned scored near 1. A city where they barely correlate scores near 0.2. Averaging these gives a single continuous measure. Look at this histogram. The x-axis is a edge weight, blue bars are scheme A and red bars are scheme B. Notice that scheme A produces a wide spread. Some edges have weight 5, others have 17. This is because it counts cities. Scheme B is compressed between 0 and 1. The mean of Scheme A in year 1 is around 7.9, meaning an average edge is supported by about 8 out of 17 cities. The mean of Scheme B is around 0.41, meaning an average two connected items have a cosine similarity of 41% across all cities. The key difference is this: in Scheme B, even cities that fall below the threshold still contribute to the average. A pair could have four cities with similarity 0.9 and 13 cities with similarity 0.3. Scheme A gives it a weight of 4, Scheme B gives it about 0.46. They tell slightly different stories about the same relationship. Now the most important tuning parameter in our entire pipeline is tau, the cosine similarity threshold. An edge only counts toward Nij if the two items have a cosine similarity of at least tau in that city. Look at the left graph on the screen. On the x-axis, we have tau values from 0.2 to 0.9. On the y-axis, the number of edges. As tau increases, edge collapse dramatically. At tau equals 0.2, the network is extremely dense. Almost everything is connected. At tau 0.5, which is our default, we get a moderate interpretable network. By tau 0.8, only the strongest relationships survive: petrol and diesel, the two Bata footwear items, cooking oil and ghee. The right graph shows the same story in terms of density, how full the network is as a fraction of all possible edges. At low tau, the density approaches 1. At high tau, it drops below 0.01. The red dashed vertical line marks our chosen default of tau 0.5. We chose this because it balances two needs. The network is sparse enough to be meaningful, not everything connected to everything, but dense enough to capture genuine economic relationships. Thank you.
Thank you. Now that we understand how the graph is made and what connections means, the next question is which items are most important? This is shown by centrality. We calculated three types of centralities. One is degree centrality. Degree centrality shows how many items are directly connected. A higher value means the item price moves with many others. In 2023, the bus mash is highest at 0.38, followed by cooked dal, gur, and then rice basmati. This shows basic food items were most influential during high inflation, not fuel. The next is the closeness centrality. So closeness centrality shows how quickly a price changes spreads to other items. Cooked dal, pulse mash, shirting, and Sufi washing soap all have nearly the same value of 0.4902. This means in 2023 the network was very connected and changes spread quickly. Next, the third centrality is the betweenness centrality. Betweenness shows which items act as a bridges. Wheat flour egg is highest at 0.1768, connecting many items. Banana link fresh and basic foods, and shirting connects food and non-food items. This means controlling wheat flour prices can impact many other items as well. Next, the toss sensitivity. This shows how results change with tau. At tau 0.2, there are too many connections, 650. At tau 0.8, too few connections, 25. But at tau 0.5, we get 208 connections, which is balanced, so we choose this value. Next is the heat map. So the heat map shows all the results of centralities together. 2023 has the darkest colors, meaning strongest connections. By 2025, colors are lighter, so the networks weakens. Items like pulse mash and cooked dal stay important in all cases. So overall, basic food items like pulse dal and wheat flour are the most important, and this result stay consistent.
Thank you. My section focuses on how this network changes over time from 2023 through 2024 and 2025, and what those changes tell us about Pakistan's economy. I will be showing you images of all the years one by one. When talking about year one, 2023, the network is the densest, 208 edges, and there are interconnected clusters and very few also isolated nodes as shown. This was Pakistan's most turbulent inflation year. The rupee depreciated sharply, fuel prices spiked, and after the IMF deal, and commodity prices cascaded through the entire basket. When everything is moving chaotically, prices happen to move together, producing many spurious but detectable core movements. Year 2, this is 2024, and the network has thinned to 98 edges, the largest clusters fragment, and this reflects stabilization. Some items began decoupling from others as specific supply chains recovered. 3, 25. This is the sparsest as it has only 45 edges, and clusters are small and isolated, and this reflects the phase where individual commodity prices are driven more by their own supply demand dynamics rather than a single shared shock like a valuation. For example, if you see these nodes specifically that are isolated, these show gent sandal, bread, and cigarettes, and their prices moved on their own schedule and disconnected from the broader basket. Now, in 9, as shown from the lines 182 to 193, this uses set theory, then the intersection of all three edges, as shown here, gives us the transient edges that are apparent in only 1 year. Bar graph. The bars look the dark blue bar on the left persistent all three represents the edges that survived all 3 years, and these are the structurally stable relationship: petrol with diesel, cooking oil with ghee, curd with fresh milk, and these item pairs are always co-moving because they share underlying cost drivers: crude oil, dairy supply chains, and that don't change year to year. The bars on the right, only year 1, year 2, and year 3, all of these are transient edges, the relationship that flared up briefly in 1 year and then vanished. The only year one bar is the tallest of these three, which makes economic sense, and 23 shocks created unusual cross category co movements that didn't persist. This three-panel chart tracks key network statistics across the years. Left panel, total edges declining from 208 edges to 98 and then to 45. And the middle panel, connected components rising from about 3 to 7 and to 20 as the network fragment. Right panel, the largest connected component shrinking, showing that the largest single cluster is dissolving. Together, these three panels tell us a coherent economic story. The 2023 shock compressed the entire price basket into one connected blob. These items gradually found their natural separate trajectories, the networks literally fragmenting over time as the economy normalizes. Heat map. This shows how stable are the centrality rankings across the years. We use Kendall's tau, a statistical measure of rank correlation computed at use Kendall tau's a statistical measure of rank correlation computed at line from 440 to 447 as shown here. Kendall tau's equal 1 means that perfect rent agreement, the same items are most central in both years. 0 means no correlation, negative means ranks are reversed. Now look at the color of the year 1 versus year 2 cell and the year 2 versus year 3. The relatively warm colors values above 0.4 tell us that the top items are fairly consistent. Petrol, diesel, and cooking oil remain central across all 3 years. However, year 1 to year 3 shows slightly less agreement, which is expected given how much network shrink. The key conclusion is this: despite dramatic changes in the number of edges and density of the network, the identity of most central items remains largely stable. This tells us that certain commodities, fuel, cooking oil, dairy, are structurally central to Pakistan's consumer price basket, regardless of the economic conditions in any given year. These items deserve special policy attention because destabilizing their prices has the maximum ripple effect across the entire network. Thank you.